Hi guys, welcome to my channel. Today's topic is evaluation of cooling system and parallel condensing system. And the topic will be covered in this video are evaluation of cooling system used in power plants, requirement of dry cooling system, hybrid cooling system, single row condenser, parallel cooling system, and comparison of dry wet and parallel cooling system. Evaluation of cooling system used in power plants. The most ancient cooling system is once-through cooling system. The condensation of steam requires a cooling medium. Water from a river, a stream, a pond or seawater is used as cooling medium. The cold water is pumped through a heat exchanger and the warm water is discharged back to the water source. This is called once-through cooling system. As it is an open loop system, it requires a huge amount of water, which is the main disadvantage of it. So there is a need to reduce the vast amount of water. Hence we require a closed loop system that is also called wet cooling system. The wet cooling tower system is based on the principle of evaporation. The heated cooling water coming out of the source condenser is cooled as it flows through a cooling tower, where air is forced through the tower by either mechanical or natural draft. The steam from the steam turbine is condensed at the outside of the surface condenser tubes using cold water coming from the cooling tower. Part of the cooling water is evaporated in the cooling tower and a continuous source of fresh water, that is makeup water, is required to operate wet cooling tower. The main disadvantage of this type of cooling system is it produces a plume, which is a visible fog exiting the tower, so a huge amount of water loss occurs. There are three kinds of losses occurs in the system: evaporation loss, drift loss, blowdown. Evaporation is water evaporated from the circulating water into the atmosphere. Drift loss is water loss due to liquid droplets entrained in the exhaust air. And blowdown is water discharged from the system of cooling tower to control concentration of salts or other impurities in the circulating water. So to achieve zero makeup water and zero liquid discharge, dry cooling system came into effect. In dry cooling system, the turbine exhaust is connected directly to the air-cooled steam condenser. That is why it is also called a direct system. Steam exiting from turbine directly go to the fin tube bundle surfaces. It has the following advantages. Those are: no makeup water is required, no plume is formed, no impact on environment. It still has some disadvantages. Less efficient. The performance of dry cooling system are primarily dependent on the ambient dry bulb temperature of the air. When the ambient dry bulb temperature of the air is higher than the wet bulb temperature, then dry cooling system are less efficient. Also, the capital cost is higher than wet cooling system. It requires a large plot area and generates more noise. Hence, hybrid cooling system and parallel condensing system came into existence. Hybrid cooling tower should not be confused with parallel condensing system. In hybrid cooling, dry and wet section is connected in a series, so water is cooled through both the wet and dry sections and is then pumped through a common condenser. So reduction of plume occurs. If only plume is the problem, then in that case this kind of cooling system is used. It has some limits also. The amount of makeup water is still significant and a plume will still be present under certain atmospheric conditions. It has practical limits to the amount of heat that can be rejected in the dry section. So thank you guys, this is all for today. See you in my next video.